Now that we're caught up on our network fundamentals, let's dive into another fundamental concept of this course. Command and control, or C2 as it's referred to in the shorthand, is the idea that we can establish a centralized command server that is capable of controlling one or more hosts across network boundaries. If you're coming from a security background, especially an offensive one, this is usually that moment when the attacker, be it you or someone else, has some sort of access to your system. A common phrasing we may use here is that there is a shell on your box, referencing the Linux or Unix shell terminology. Now before we talk about command and control, I actually want to go over basic client-server communications. Now normally when you use the internet, you're probably using a browser running on your computer and you're accessing websites via that browser. Now from a network perspective, you're the client, and the browser is just a medium for you to view your chosen content. But the network traffic itself at the end of the day looks like it's coming from your host, or more specifically, your network, in the sense of a standard router, modem, home internet connection. Now, there's a server on the other end, and this server is a web server that is hosting the content that you're trying to view. This content is served on the page and then accessed by you. From a network perspective, this communication is occurring from client to server. The server had to open up a port for you to access it, but you didn't have to do anything special on your network configuration. All you had to do was access the server. Even in scenarios where communication may appear bidirectional, it's still technically all from client to server. The server never has direct access to any services or hosts on your network outside of the general established communication over the application and protocol that you as the client have initiated. If a web server needed something from you, technically it does know your IP address after you've contacted it, and it could try to reach out to you. But unless you are purposefully allowing something into your network, its attempt to reach out would fail. But let's say you did for a moment. Let's say you hosted your own web server on port 80, and anytime you browsed to your favorite website, it called back to your IP on port 80 to fetch whatever content that you had there. Now the server is communicating with the client, and you could even argue that you are a server now as well. That's logically why it's called a server. You are serving content for some client to consume to some extent, and now the server is your client. When it comes to command and control, or C2, this is the exact same concept. You as an attacker maintain a server. This server acts as your command station of sorts to execute tasks on the system or systems that you control. However, this whole concept of who's communicating with who is now far more important in the C2 context. You see, when setting up our C2 implants, oftentimes we have the option to connect to our client or make our client connect back to us. This is where the terminology of bind and reverse shells come in. Those of you who are familiar with the Metasploit framework might have seen those before as part of your payload options. From here on out, we are operating from the perspective of a C2 server. So we are the server and the client is our target. In the case of a bind connection, we would run our C2 implant on the target or the client, and it would actually open a port on the client that we would connect to. This direction is from our server to the client, and it's known as a bind connection because we are binding to our target service via our implant. The trick here is that if our client is behind any sort of firewall, or if we don't have proper privileges to open a port on the target itself, we won't be able to reach our service that we want to bind to. So, the other option we have in this scenario is for the client to reach out to us. This is known as a reverse connection. In a reverse connection, the implant on our target is going to beacon out to our C2 server either at a given interval or if it's like a socket connection in real time. This is much like how you can both send and receive data from a website, but you're still only connecting out one way. In the same manner, this implant can send and receive instructions from our C2 server with only calls in the reverse direction. And it's called reverse because we are coming from the perspective of the C2. In the context of a bind connection, we are talking to our target, whereas in a reverse connection, that flips the direction around, or reverses it. Now, the directionality is a bit of a trivial thing, but it is super important as there are pros and cons to each type of connection. While reverse connections are more common to use as they avoid many firewall-related issues and are generally more portable and applicable, both the options still exist for a reason, and it's important to understand the purpose and directional distinctions. Now let's see this in action using Metasploit. We've got a simple system here that's actually vulnerable to Eternal Blue, or MS17010. We're going to start off by configuring a bind shell payload in the context of this exploit, and we're going to try to connect to our target with it. So this is just for proof of concept to demonstrate the kind of difference between bind and reverse shells. We're not going to focus too much on like process or pen testing. In fact, this course isn't about pen testing or even the red team process. It's about offensive security engineering. So just keep that in mind. We're going to kind of just be assuming some things. So in this case, we can look at our options, and we're already configured here with a reverse TCP shell that we're going to change. But we see we've got a target at .2.104. And we're going to go after that. So the first thing I want to do is change this to a bind payload. So if we say set payload and do a little tab autocomplete, we can see our payload options. And you'll actually see that you have a lot of different options for both reverse and bind type payloads. We're going to stick with a typical interpreter payload. So we need to use the Windows 64-bit interpreter bind TCP payload. Now if we look at our options, it's pre-configured from our hosts in the actual exploit, and we're going to leave all the defaults because it doesn't really matter for this demonstration. So quad 4s is what the client should be listening on. If we're able to connect to it successfully, we should be able to go. Now this exploit does have a chance to crash the target, so if so, I'll cut the video to get to the point in the demo where everything actually works. So that's the danger with Eternal Blue, but it's easy, it's fun, and we're going to do it. So starting off with a bind connection, I'm going to run this exploit actually as a background job, just kind of a habit of mine. I like to be able to continue to interact with the console if need be, although by default this exploit's very verbose and we're not going to be doing anything anyway, so it's not really necessary. But as you can see, our host is likely vulnerable, and we've got a interpreter session open. So interpreter session 3 has opened. Awesome. So now we're going to reconfigure our payload to actually be a reverse payload. And then we're going to take a look at some of the differences that are even just displayed within the Metasploit console. So back to the 64-bit interpreter payload, and this time we'll select reverse TCP. It's got our options pre-filled. We are at .2.169. It's pre-filled from a demo I did earlier, so that's all. But otherwise, you just do an ifconfig. Everything here is just local, so we're not getting into any actual big C2 yet. This is all just basic Metasploit stuff right now. So we're going to exploit this as a background job as well, and hopefully not crash the host. Awesome, exploitation successful. Now, if we take a look at our sessions, we can see a couple things here. First off, we've got 2 system sessions, and that always feels good. But the thing I want to notice about session 3, so this is our bind session. It's showing that we're coming from 000. So this is us. We don't really care what interface we're coming from, localhost, whatever. It doesn't really matter. We're coming from us. This is coming from our space and binding to our target here on port quad 4s. That's a pretty clear distinction. The directionality is there. We can clearly see based on the IP addresses and directionality where we're going. The way Metasploit represents reverse shells, though, is a little bit weird, and I actually kind of don't like it because the arrow kind of throws you off. But if you just pay attention to the actual, addresses, that's what really matters. And so you know that we're on 169 on port quad 4. So you know this is us and our listener. We're hosting the actual C2 here. And you can see on our target, 2.104, it's coming from an ephemeral port. So it's coming out of 50,000, 60,000 ports, which is exactly what we see here. So even though this arrow is pointing to this host, this is just to represent that, hey, this is the target that we've taken over. It's not really a directionality thing. So I would prefer if it was represented otherwise. That's just a personal thing. But that's why I wanted to line up the bind shell right next to the reverse shell. So you can see the clear differences of what it looks like when you have a bind shell versus a reverse shell. And just to show that these sessions actually do work and everything's working nicely, we'll go run a quick get UID on these, show that we have some nice system shells. So that was the bind shell and our reverse shell, and everything's working awesome. So that is the most fundamental thing to understand about all C2s. A C2 server does nothing more than follow a simple client-server model. In fact, we make C2s sound like this big, fancy, scary thing, but it's just a piece of server software. The only difference is it's purpose-built for, feeding commands to some other program that's going to take those commands as inputs and then execute them on the target system. But honestly, it's really not that different from many remote administration tools. Arguably, that's all C2 is. It's remote administration repurposed for offensive security. Now, don't get me wrong, there can be ethical implications in software. A program that's designed to destroy a system could be argued to be malicious in nature on its own. But at the end of the day, a Meterpreter payload isn't inherently malicious. You could totally use it to perform legitimate remote administration tasks. Now, does its feature set empower you to act as a threat if you want to? Absolutely. But the software alone is just a piece of remote control software. This course, however, isn't on ethics in software, so I'll kind of leave it at that. It is worth mentioning, however, just to help you think about C2 software differently. That mindset of how the software works fundamentally and its purpose will help you when exploring new C2 frameworks and even help you later in this course. I hope you enjoyed this lecture, and I hope your shells didn't die like mine did. We'll catch you in the next section.